Okay. Okay. Okay, cool, excellent. It seems everything is working, so let's get to it. So, hi everyone. I hope you can hear me well. So today what I'm going to do is I'm going to be doing a pull request on jaxopt. And so the pull request basically stems from the fact that at some point it was Vincent Roulet, who's one of the main contributors of jaxopt. He basically wanted to implement a better line search, and in particular he wanted to be able to not take any step when the line search in jaxopt was failing, just because, for example, you didn't have a decent direction. So what I'm going to do today is fix a bug that was uncovered in the Broyden method, because for the first iteration it doesn't give a decent direction. So maybe a little bit of context. Actually what I answered Vincent was that I don't think that Broyden method probably gives decent directions without further assumptions. And I think that in particular you need a good initialization of the Jacobian approximation denoted B here. And so what I'm going to do today is exactly implement this better initialization of the Jacobian approximation. Yeah, I forgot. I needed to tweet that I was starting this session. Not that I think it will be particularly important, but just okay. So first thing is I need the inspiration to have the perfect, not the perfect, but the one of the best initialization for the Jacobian approximation. And this approximation, I'm just going to take it from SciPy. Actually, so it's given here. So generally, this is Jacobian approximation that you find in the Broyden method. So just to recall the Broyden method, I'm just going to slightly explain what it is. Like being on Wikipedia is the best. So basically, we want to solve this type of equation. So f of x equals 0, so it's called the root equation. And usually, when you have Newton's method, you use the Jacobian matrix of f. But sometimes it's costly to compute, it takes a lot of memory, so you want to rather have an approximation of that, especially because you want to invert that Jacobian. So it's better to directly go with a low-rank approximation that is itself easy to invert thanks to the Sherman-Morrison formula. And so basically this is how you build this Broyden method, but at some point you need, because the Broyden method has these iterations, where Jn is the approximation of the Jacobian, you need to have J0. And J0 sometimes is the identity, but sometimes it's the identity multiplied by a scalar. And in particular, if you take the identity or minus the identity, sometimes a direction might be a decent direction depending if J0 is I or minus I. And so it's important to have a good one, because otherwise the line search is not going to work. And so it happens that SciPy has a nice initialization, and for now in jaxopt we left this parameter that we called gamma. So unfortunately there is a bit of a mismatch here, and gamma is initialized with just one, and you can change it like the user can change it. So what I'm going to do is I'm going to do a PR where the user can specify what should be the that you should use SciPy initialization for the Jacobian approximation in Broyden method. And so yeah, we're going to see exactly what are the different settings that we should give to the users. Okay, let's start. So I'm going to say fix Broyden jack approx units. Okay, let's go. So for now, I'm just going to like write shitty variable names. I think afterwards I'm going to basically change them to something better, maybe iterate with the other contributors of jaxopt. So I'm going to say maybe compute gamma. I know that in LBF.js it's something a bit different, but for now I'm going to stick with that and change it afterwards. Let's get it working first, and then we're going to make it nice. Okay, so this is going to happen here. So I don't know if I should recompute gamma if you are initializing from an opt step. And my guess is that no, but I'm going to write a comment about it somewhere. So I'm going to say not initializing, not computing the Jacobian init approx when starting from an step object. So basically, because sometimes you want to be restarting Broyden from a certain point, I don't think that in these cases you necessarily want to recompute gamma. I think it's the user's responsibility to recompute gamma if they want. But in the other case, we are going to say that if self.compute gamma, we're going to compute gamma using the SciPy formula. So we use SciPy's formula, and I'm going to cite the always cite. I'm going to cite this. I don't need actually. I just need this, I think. What does it give me? This. Yeah, it's what I need. Okay. And else we're going to have gamma is self.gamma. So the user specified parameter. And we're going to initialize the state with this computed gamma. And so SciPy formula, I'm going to copy paste it, and I'm going to say that gamma is equal and now the question is, do I compute somewhere? Ah, yeah, here. I compute it here. So see here, I compute the value of the function. And so my guess is that I should not recompute the value anytime. Like twice. And so basically, I think what I'm going to do is I'm going to have it, put it here. And I need to have two different cases because here init params comes from the params of the opt step, and here it's actually given by the init state. So it's a bit different. So that's why there is this bisection of cases. Okay. And so here I'm going to have it. I can have it here. I don't need to change anything. And so value is basically going to be norm of f0. What I can do now is say, okay, norm f0 is going to be 3L2 norm of value. Norm x0, thank you, GitHub Copilot, is going to be 3L2 norm of init params, dot param, no, init params. And gamma is going to be 0.5 times blah, blah, blah. Okay, so I think maybe no. Here this doesn't work. I need 3 max. Do I have 3 max or something? No, I don't have 3 max, but that's what I need. In 3 util, do I have 3 max? I don't have 3 max. That's too bad. Okay, so basically here the reason I'm making a fuss of this is because so value and init params, they're basically trees, so it means that they're not vectors necessarily. They could be trees of vectors. In JAX, basically trees are just any structure that itself contains vectors. So you could have like dictionaries, lists, etc., and they could be nested. And basically, at some point, you reach a leaf which is not something that is identified by JAX as something that cannot be can be a tree. So, for example, if you have a custom object, it will be considered a leaf by JAX. But lists, tuples, dictionaries, they basically allow you to form trees. And so here you want to use tree map of wait, no, it's not tree map. No, I'm confused because wait, I'm confused. I'm not sure what I want to do here. I'm not sure what I want to do because so here do I want gamma to be tree-like, or do I want it to be because I think I want it to be tree-like. Yeah, I think that's interesting, because basically when you're handling a tree in all of these optimization algorithms, you're considering it separately. And in particular here, you can see that whenever you're doing anything to this parameters, you're actually considering it separately. You're computing different Jacobian approximation per leaf of the tree. So you have an in-Jacobian product, which itself is applied leaf-wise. And so my guess is that actually I don't want to have a gamma that is a float. I want to have gamma that is tree-like. I want to have gamma that is tree-like actually. That's interesting. So I don't want tree L2 norm. I want to map L2 norm. Yeah, that's what I want to do. I want to map L2 norm on value. Similarly for the params. Because I don't want to take the norm of the vector as a whole. Or is it what tree norm does? I don't remember. Yeah, see, it maps and then it does. Yeah, it reduces. Tree sum reduces. I don't want to reduce. I just want to map. I want to take the norm of the. I don't want to take the norm of the full vector. I want to take the norm per leaf. And so here again, I'm going to do tree map of the max between norm. So no. What I'm going to do is I'm going to compute. I'm going to initialize a function. So I'm going to call it max1, and it's going to be a lambda function. I'm going to write it directly actually. So I'm going to say the lambda function is gnp.max between, so it's going to be lambda of x between x and 1. And it's here, it has to be norm x0. So this is just norm of I'm gonna call it, what can I call it? Clipped norm x0. And I'm gonna say it's 0.5 times 0.5 times this, and it's JNP blah blah blah. Okay, and now I'm gonna say that gamma is tree div. Do I have tree div here? Okay, no, I don't have tree div. I just need to import it. So for some reason it's imported like on each single line. I don't understand that. It's okay. For now it's not necessarily an issue, but I just don't understand. And tree div, I'm not sure exactly how it works. I'm just gonna write it and we'll see. Tac. Yeah, okay. It's tree div between clip norm x0 and norm f0. And so an interesting part is that when norm f0 is 0, then we just say that gamma is 1. Maybe there should be some kind of mechanism to make sure that if we divide by 0, there is not going to be any problem. Maybe I'm going to have a safe divide by 0 function which just gives 1. Yeah, I'm going to do that. I'm going to say def safe divide by 0. And it's going to be x, y, return, return gnp count. I'm going to write it for user Copilot. I'm just going to say a division, a classic division, classical division of x by y. When y equals 0, then return 1. And I'm going to say return gnp, where exactly, I think that's what I want. Okay, perfect. And I'm going to do a tree map of this. Okay, and now what I want to do is I'm going to change actually this gamma. And I'm going to change a bit the way everything is computed, so that gamma actually is tree-like. Repeat gamma in as a pi tree of the shape of init params. And so gamma gonna be tree map from the x gamma of init params. I don't know if it's the most efficient way to do it. Honestly, for now, I don't care. And I'm gonna say that it's jnp.array of gamma. And here I'm gonna say it's gamma. Okay. And so yeah, gamma basically didn't specify, but it's basically the Jacobian approximation initialization that we have is gamma times identity. And so that's what we are doing here. We're computing this gamma. Okay, so that's just for the initialization. And now what I need to do is change how gamma is used. Because basically here, it's in the Jacobian product keyword arguments. I'm just going to make sure that it's all there is. And so, but basically, what I need is to change the way the inverse Jacobian products are computed. And in particular, I don't want now that gamma is repeated. Gamma is not going to be a scalar. It's going to be a pi tree with scalars to use for the initial inverse Jacobian approximation. And now gamma is going to be used here. And I don't think I need to change it anywhere else. Yes. And here it's not going to be an NP array, it's going to be any. Now it's a pi tree, it's not necessarily so it's not going to be an array. It's not that it's not necessarily, it's not going to be an array. Okay, I think we're on. So yeah, I don't see anything else that needs to be done. So we'll see now if it works in the tests. Okay. So I did the initialization, the computed initialization of the Jack approx in Broyden. Okay, perfect. So I'm gonna create a pull request. I'm just gonna have it as a draft PR for now. I need to run the existing tests and add the previously failing test written by @virole in a previous PR. And this previous PR, the test was this one. I'm going to specify that in order to implement this change, I had to change how the type, the D type of gamma, which is now a pi tree rather than a scalar, since it can be different for each leaf of the parameters. Okay, so I'm going to create that draft PR and I'm going to run the tests. So I'm just going to run the base tests and the common tests just to make sure that everything is running perfectly. Oh, it's nice. So in the new VS Code, they have this test results tab that I didn't know existed. I think they changed also the way they identify tests, and that now they're much more failure resilient. Okay, and now for the moment of truth, I'm going to run Broyden. Let's see if the existing tests all run. If they do, I'm just going to add this previous test by Vincent. And they don't. Aha, interesting. So, I see. Conjugate requires ND array or scalar arguments. Got class tuple. Aha, that's super interesting. And so that's because here I did NP conjugate of gamma, and I'm gonna have to do gamma conj is tree map of gamma, and so that's gonna be much better. I think that should work. I think that should work. I'm particularly happy with the fact that all the other tests are running. So, oh yeah, but I didn't change weight. Did I make sure that compute gamma is false? Okay, so I didn't test my change actually. I didn't test my change. So corrected right product gamma. Okay, and so yeah, basically maybe I want compute gamma to be true all the time actually. I think I'm going to have to debate this, but I think at least, so in SciPy I think it's the case. In SciPy, I think that there is always the autoscale, so I'm going to check it actually. That's Broyden first. Yeah. You init. And then no, self.alpha equal alpha. So that's interesting. And I'm also like here when I see this minus, I'm a bit concerned. I'm thinking maybe like there is a sign mistake somewhere. I will need to check this actually. And so here what's interesting is that they do like when in the example they give, they do not specify an alpha. But here it seems that it initializes without taking into account the alpha. And then they say that they reset basically alpha, which is none by default. And then I'm not sure exactly. They run the setup of generic Broyden. Aha. And so I think maybe it's in the setup of generic Broyden. Yeah, it's in the setup. So it's in the setup. I thought it was in the init, but it's in the setup they compute it. And so basically here in Broyden first, they run the setup of generic Broyden. I think they run it, they have to run it somewhere at some point. And similarly in Broyden second. And I think that then, when you do non-lin solve, at some point they must initialize it, or yeah, they do Jacobian. So Jacobian is what we're looking for. Yeah, they do setup. Okay, so they do as Jacobian of Jacobian. So what is this function? And this function is going to be, if you have a callable blah blah blah, and if you have a string now, you just have the default, and the default is that alpha is none. And so if you use Broyden 1, you're just going to have that computation. And the question, so it's going to be compute gamma should be true if you want to have the same behavior as SciPy. So now let's run the tests with compute gamma is true. And they all fail. And they all fail. Okay, that's interesting. And so let's see if the base test and the common test pass. So they also fail. They also fail. Okay, that's super interesting. That is super interesting. I need to know exactly why they fail. Okay, so let's see this one for example. Axis 1 is out of bounds for array of dimension 0. Okay, and endcalls is failing as well. And it's for the same reason. So where does it happen? I think it's just because I'm using max wrong. Okay, I think it might be GNP maximum or something. Element-wise maximum of array elements. Okay, so I need to use maximum, not max. Yes, okay. I can rerun command test. I'm always confused between max and maximum. It's the type of thing you never get used to it. Okay, still failing. Array implementation has no attribute iter number. So where does this happen? Okay, so this I don't understand. Okay, so this, it comes from it's actually not here. It's a bit weird, or at least I think it is not here. It is here. It is here. So here I'm doing state start is eternum modulo self historicize. And here what it says is that this object, which is array implementation, does not have this attribute, iter number. Okay. That's weird. Why so? Okay. Okay, I'm gonna run this in debug mode and see. Like, first thing I want to see if it stops at the right time. Okay, so it stops, and so now it says that state is an array. But state is not an array. I know. It shouldn't be an array. So why does it think that it's an array? I'm gonna close variables and watch, and I'm gonna say that it's in run, and it thinks that states. Okay. Init state. I wrote return gamma for some reason here. I don't know why that was. I think it might have been just, I'm gonna blame it on GitHub Copilot, just because it's easier for me, but I'm not sure. Yeah, it seems to be running now. Yeah, it seems to be running. So I guess it was just an error due to this. It was just a typo, basically. At least for the number of calls test. I think number of calls should be fine because we're just running it with like this value in aux. It doesn't change. We still have just the one function evaluation. That's it. Yeah, I think it should be good. I'm just gonna run them in parallel so we can gain time and actually like focus on if there is something in the logic of Broyden that doesn't work. These other tests are basically just testing, I would say, not sugar, but you know, like little things like how many times do you call the function, and it doesn't work for something, so that's interesting. But it works for all the common tests, so that's great. That's great. It means we have an error at some point. What's interesting though is that so here I need gamma is -1, and it says basically I think this was the error I was talking about. So basically I have something which is going to be a positive rather than negative, and so okay, I'm just gonna debug, and I just put a breakpoint here, and so here no, but I don't want to run all the Broyden tests actually. No, but I was just running the contractive mapping, so that's perfect. So I put a breakpoint here just to look at the value of gamma that I computed using compute gamma, and see here it's positive, whereas we know from this test that it should be negative. And so I think that here it's actually a minus. It has to be, because they use it in the other way in SciPy. And now I'm going to remove the breakpoints. I'm going to look at the tests. I don't remember. It's Shift-KT. Okay, it doesn't work. Anyway, so I'm going to run now all the tests, obviously, and see if with the minus is better. No, it doesn't change. It's much better because it's still it's in the right order of magnitude, so that's good. And here it has a none. Okay, interesting. Okay, so I think it was a minus. So here I'm just gonna change the tolerance because, yeah, I mean, we don't care. Yeah, I'm just gonna say it's 5 e minus 6. Doesn't really matter. But I think it's interesting. So I'm just gonna say that I'm gonna add this, and I'm gonna say few corrections to gamma computation, and I'm gonna say that I lowered the tolerance, actually increased the tolerance for a Broyden test. Okay, I think I'm gonna stop the stream here. Obviously, it's a bit of a cliffhanger because I still have a problem. But other than that, so I think we're looking good. So I'll see you at the next coding session. Cheers. So